Hi everyone. In this video, I'm going to explain a few problems related to greatest integer function and fractional part function. In the previous videos, greatest integer function class 1, I have explained what is greatest integer function and how to draw the graph of greatest integer function. In the class 2, I have explained a few properties, not all properties, a few properties which are required for JEE Main and JEE Advanced. I have explained in class 2. And I have explained what is fractional part function. Now in this class, you will learn how to solve questions involving greatest integer function and fractional part function. So before we going into the questions, just I'll give the outline of once again greatest integer function and fractional part function. Here you look at here that if you give any real number, then we can write that real number as sum of two things. One is an integer, another one is a fraction. Fraction is never negative. It is always lies between 0 and 1, but not 1, including 0, excluding 1. So here x equal to n plus f. X equal to n plus f. You see. N belongs to Z, F lies between 0 and 1, and X lies between two consecutive integers, lower and excluding upper, N and N plus 1. Then we define that greatest integer value of X, right? Integral part of X, we take only left side integer, that is N. This one. We consider this only integer part. And second one, what is fractional part of X? Fractional part of X is nothing but F. We subtract that integral part of X from given real number. X minus integral part of X. Right. So once again, what is integral part of 2.5? Integral part of 2.5 equal to 2. Integral part of minus 1.6 equal to minus 2. Minus 1.6 lies between minus 1 and minus 2 and minus 1. We always consider left integer. And E value approximately 2.718. Okay, these are the basics. Pi value approximately equal to 3.14. All right. So let us discuss a few questions based on greatest integer function and fractional part function. Here is a question of previous IIT 1991. F of x equal to cos of integral part of pi square into x plus cos of minus integral part of minus pi square into x. All right. Here we have an integral part of pi square. In the class 1, I have explained how to find out integral part of pi square, integral part of e square, etc. Here you see. So here pi square value approximately 9.19, 9.19, which belongs to 9 and 10. Similarly, minus pi square belongs to, in reverse order, minus 10 to minus 9. All right. Question is quite simple once you understand what is integral part of x. Every real number can be fit between two consecutive integers. We always consider that left integer. All right, you see. So here f of x equal to, now what is integral part of pi square? Integral part of pi square is nothing but 9. We consider left integer. So f of x equal to, we write cos 9x, cos 9x plus cos of, what is integral part of minus pi square? Okay, integral part of pi square equal to 9 and integral part of minus pi square. Integral part of minus pi square equal to minus 10. You always remember that we consider left integer. So this is cos of minus 10x. So now we got a function that cos 9x. Cos of minus x is same as cos x. So I can write this is plus cos 10x. Now they are asking that which option is true. So we have to verify that each option. We have to verify each option. All right. So what is f of pi? I am checking option B. What is f of pi? Because it is easy to check integral multiple, cos of integral multiple of pi. F of pi equal to, in place of x, you put pi. So you will get cos 9 pi plus cos 10 pi. I need not to explain each and everything, that cos 9 pi value is minus 1 and cos 10 pi value is 0. That is equal to minus 1. So option B is wrong. Option B is wrong. Since cos of minus x is nothing but cos of x, so f of minus pi is same as f of pi. So its value is also minus 1. So option C is wrong. Now what option can be true? Right. Let us check option A. What is f of pi by 2? F of pi by 2 equal to, you substitute x equal to pi by 2, we get cos 9 pi by 2 here, plus substitute here x equal to pi by 2, you will get cos 5 pi. Cos 5 pi. So this is equal to, cos of odd multiple of pi by 2 is 0. Cos of odd multiple of pi is minus 1. So this is equal to minus 1. So therefore option A is true. So what else are required to solve this question? Little trigonometry is required. Cos x is 0 at odd multiple of pi by 2. Cos x is 1 at even multiple of pi, like cos 2 pi, cos 4 pi, cos 6 pi, 1. And cos x is minus 1 at odd multiple of pi, at odd multiple of pi. So this is the question. So in this we have used that how to find out integral part of pi square, integral part of minus pi square. They may ask integral part of e square, integral part of minus e square, etc. Well, moving to the next question. We need to solve two equations involving greatest integer functions. Y equal to 3 into integral part of x minus 2. Y equal to 3 into integral part of x minus 2 plus 5. Asking what is integral part of x plus y. So what are the basics that we require to solve this question? The basic point is that integral part of x equal to n if x lies between n and n plus 1. Output of integral part of x is always an integer. Okay, n is an integer. Second one, integral part of x plus k. You can bring out k from that integral part if it is an integer. If it is an integer. Otherwise, we cannot bring it out. K is an integer. So these two will apply here. Well, here you say that first equation is a very straightforward. I'll take a second equation. I'll take the second equation. All right. Okay. Or I'll equate both. I'll equate both. Here this is y and this is y. So solution is straightforward that from given two equations, I'm equating both. So 3 into integral part of x minus 2 equal to 3 into this I can write, I can bring out minus 2 out. So 3 into integral part of x minus 2, okay, plus 5. All right. Okay. So here something fishy is going on that maybe that 3 into integral part of x is cancelling out. Okay. I'll check it out once. As such, given equation has no solution. As such, given equation has no solution. So I am just changing this equation by like this. I am not taking this 3. Okay. All right. Now I am removing this 3. Well, so now what are the equations? Y equal to integral part of x minus 2. Y equal to 3 into integral part of x minus 2 plus 5. All right. This implies, see, this is integral part of x equal to 3 into integral part of x. Okay. This is minus 6 plus 5 minus 1. Bring this minus to this side, you will get plus 1. All right. Okay. And here integral part of x, output is always an integer. Okay. As such, now also we have no solution. 2 into integral part of x equal to, we get minus 1. This implies integral part of x equal to minus 1 by 2, which is impossible. Which is impossible. I'll give one more question. Which is possible? Which is impossible. Therefore, given equations has no solution. Given equations has no solution. Equations have no solution. Like the system of equations which we have given has no solution because integral part of x, that output is always an integer. Okay, I can prepare one more question based on that which has a solution. Okay, okay. Now coming to third question. Third question is quite simple, I hope. Okay. All right. Solve integral part of 2x equal to 1. Solve integral part of 2x equal to 1. Solution. Okay. Here that output is 1. So this quantity should lie between 1 and 2. Remember. So integral part of 2x equal to 1 implies that 2x should lie between 1 and 2. You start with the given integer and go to the next integer. That's it, over. If they have given right side 2, 2 to 3. If they have given right side 4, 4 to 5. If they have given minus 4, minus 4 to minus 3, like that. Now this implies, now divide by 2. 1 by 2 less than or equal to x less than 1. This is the solution. Therefore, answer is x belongs to closed 1 by 2, open 1. Integral part of 3x equal to 1, integral part of 4x equal to 1. However they give, it is very simple. Now, for example, I can take one more example based on this fact that I'll take that 3a. For example, integral part of 3x minus 1 equal to, you take some minus 2, like this. So how can I write this? That integral part of 3x, you bring out that minus 1 and bring this side, you will get minus 1. So here 3x should lie between minus 1 to 0. Now divide by 3, minus 1 by 3 to 0, minus 1 by 3 closed and 0 open. Like that, by yourself you can create the questions and you can solve them. Coming to the next question. Integral part of r by 3, where r running from 1 to 100. R running from 1 to 100. Right? How to solve this question? Well, done. You see, I'll try to list out every term so that you can understand easily. I'll write that integral part of 1 by 3 plus integral part of 2 by 3 plus integral part of 3 by 3 plus integral part of 4 by 3 plus integral part of 5 by 3 plus integral part of 6 by 3, like this and so on. At last, I'll write a few terms that integral part of, okay, all right, 96 by 3, integral part of 97 by 3, plus integral part of 98 by 3, okay, plus integral part of 99 by 3, plus integral part of 100 by 3. 100 by 3. All right. Now we'll calculate each term and we'll see that if we may get some kind of pattern. All right. See, 1 by 3 lies between 0 and 1. So its integral part value is 0. Integral part of 2 by 3. 2 by 3 lies between 0 and 1. Integral part is 0. Integral part of 3 by 3, it is an exact and integer. So its value is 1. Its value is 1. Integral part of 4 by 3 is 1. Its value is 1. Lies between 1 and 2. Its value also lies between 1 and 2. And this is 2. All right. Okay, like that you will get. So its value is 33. This is 33. And this is 32. All right. And this value is 32. And this value is 32. And this value is 33. Now, how do we calculate its value? Seems to be a little difficult, but it's not at all. All right. So if you observe, okay, I'll write this. You see here 1. This we got that 1 how many times? 1 we got 3 times. 1 we got 3 times. Like that, 32 how many times we got? 3 times. So 1, 3 times. 2, 3 times. 4, 3 times. Up to 32, 3 times. And 0, 2 times. Last 33, only 2 times. Okay. So that I am going to write now. So this is equal to 0 we got twice. So 0 into 2 plus 1 we got 3 times plus 2 we got 3 times plus and so on up to 32 we got 3 times into 3 times plus 33 we got 2 times. We got it. We got it. So I am just listing out that individual terms and then calculating. 1 we got 3 times, 2 we got 3 times, 4 we got 3 times, 32 we got 3 times, but 33 not 3 times, only 2 times. All right. So this is equal to first one anyway 0. I am taking 3 out. 1 plus 2 plus and so on up to 32. This is an AP series, okay? Our sum of first n terms is n into n plus 1 by 2 into 3 plus it is 66. So this is equal to 3 into n plus 1 into by 2 plus this is 66. So now further you can calculate it. It is very simple, okay? Right, this you can cancel by 2 16s. So that's equal to, all right, I can take that 66 common, okay, into here 3 into 8 is left. 3 into 8 plus 1 is left. So this is equal to 66 into 25. I don't want to write that complete answer. You can finish that. So like this, you can give integral part of r by 2, integral part of r by 4, integral part of r by 5, etc. Right. Okay. Now, I'm going to explain one previous JEE mains question with alternate series, inside the greatest integer. Now, previous example without alternate terms. So this also you can solve if you can write term by term and observe that. Write term by term and observe that. This is the question sigma n equal to 8 to 100. 8 to 100. Integral part of minus 1 whole power n into n by 2. You try to list out individual terms and you see that the value of each term, what it will be. Remember, integral part of x equal to n. If x lies between n and n plus 1, n is included, n plus 1 is excluded. Well, okay. So let us list out the possible terms of this given summation. Okay. So here, take care that n starts from 8, not from 0, 1, 2, etc. N starts from 8. Okay. All right. Just a moment. I'll solve this question. Sorry for the interruption. Now we can solve this question by listing out individual terms. Sigma n equal to 8 to 100. Okay, integral part of minus 1 whole power n into n by 2. This is the given summation. Now put n equal to 8. Put n equal to 8. You will get 8 by 2. Put n equal to 9. You will get alternate series. Put n equal to 9. You will get minus 9 by 2. Plus alternate. You write alternately. 10 by 2. Plus integral part of minus 11 by 2. Plus integral part of 12 by 2. Like this. Okay. Plus and so on. Plus and so on. We'll write last a few terms. Last a few terms that integral part of 98 by 2. Plus integral part of minus 99 by 2. Plus integral part of 100 by 2. Okay, right, all right, all right. So we have listed out all possible terms. Now we'll write those individual values. The very first one, integral part of 8 by 2 is nothing but integral part of 4. Okay. And next integral part of minus 4.5. Plus integral part of 5. By this time only you would have got an idea. Minus 5.5. Okay. Just you are increasing by 0.5 alternately. 6. Next you can predict that 6.5 minus. Okay. Okay. I won't write. And so on. What are the last two terms? Integral part of minus 49.5 plus integral part of 50. All right. Anyway, integral part of an integer in integer itself, it has no fractional part at all. Right, fractional part is 0. So here I can write this is 4. Okay. Observe that what is the sum of these two terms? What is integral part of minus 4.5? You will get minus 5. Minus 5. Because minus 4.5 lies between minus 5 and minus 4. You consider that left one. Plus integral part of 5 is 5. Got it. Now you see Pair up this. Integral part of minus 5.5 is minus 6 and integral part of 6 is 6. I hope you can continue this sequence. Next, minus 7 plus 7 and so on. At last, minus 50 plus 50. Well, each bracket value is 0. Each bracket value is 0. This is 0. This is 0. And this is 0. So we got answer 4. So very easy, very simple question once you understand what is greatest integer function. What is greatest integer function? All right. If y equal to, I'll give one question that 3 into integral part of x minus 4 and y equal to some 2 into integral part of x minus 2 plus 5. Then, okay, then what is integral part of x plus y? What is integral part of x plus y? So in this entire class, I am discussing only questions based on integral part as well as fractional part. Maybe here till now, I didn't solve any question of fractional part, but I can solve in the next class. Well, all right. So how to solve this question? Okay. So first of all, here, this is one equation, y equal to something and y equal to something. So you can equate directly, right? X equal to A and X equal to B implies A equal to B. X equal to A and X equal to B implies A equal to B. All right, equate these two, that 3 into integral part of X minus 4 equal to 2 into integral part of X minus 2 plus 5. Okay, implies 3 into integral part of X minus 4. Try to remember that basic concepts of and basic properties of greatest integer function. You can bring out 2 minus 2. So I can write this is 2 into integral part of X minus 2. You can write that minus 2 outside of that bracket. Further, you can write 2 into integral part of X minus 4 plus 5. This is equal to 2 into integral part of X and plus 1. All right. Simple. Now anything can be cancelled out. Here we have 3 times of integral part of X. Here 2 times of integral part of X. So you cancel 2 times of integral part of X. Then only one integral part of X is left. Bring this minus 4 to the RHS. You will get 5. So integral part of X equal to 5. Which means that X takes the values between 5 and 6, including 5, excluding 6. This is the X interval. All right. Integral part of X plus Y is not equal to integral part of X plus integral part of Y all the time. That happens only when they are integers. All right. Okay, maybe some other reason will be there. I'll explain. Now substitute here. Substitute here. Y equal to 3 into 5 minus 4. That's equal to 11. So therefore, integral part of x plus y. Okay, I want that integral part of x plus y equal to, we got directly y is 11. So I can write integral part of x plus 11. That's equal to integral part of x plus 11. What is integral part of x? Here we got integral part of x equal to 5. So this is equal to 5 plus 11. That's equal to 16. We have solved this question. Okay, so in the next class, again I solve some more questions based on properties of greatest integer function.